Hi everyone. So how are you doing? Hello Yamini. Hi Satyam. Hello Dibyanshu. Hi Vivek. Hello Vishwanath. Hello Sangeet. Hi Vivek. Hi Mohit. So let's get started, right? So today we are going to start a very new topic, which is sliding window protocol. Okay. So we have finished our first protocol, which was stop and wait protocol in the flow control, right? So in the flow control, we were seeing some protocols, and one of them was stop and wait protocol. That's what we have already finished. Now let's start with the next protocol, which is sliding window protocol, right? Okay. So let's get started here. Now, if you remember in stop and wait, what we were doing, we were saying that in stop and wait, we were saying that if you want to send some data, right, then you can send some data, like for example like this, and then wait for the acknowledgement, right? I mean, if you're sending some frame, that is fine, and then you are waiting for the acknowledgement, which means that once the acknowledgement is arrived, then you are sending the next data. Do you remember this? That is called stop and wait. I mean, this is what we are waiting. But do you really think that we should be waiting for this much time? Does this make sense to wait for this much time? The answer is no, right? So hence we have our next protocol, that is called sliding window protocol. So in the sliding window protocol, what we say that we will be keep on sending in this time also. So what is the time is in our hand? Do you remember that we have talked about this time, which is called RTT, right? Right. Okay. So time in our hand, it's called RTT. By the way, have you solved all the questions of stop and wait? I mean, at least in the lectures, whatever we have solved, was those questions fine? Were those questions fine? Okay, great. So Yamini is saying yes, Mohit is saying yes, Sangeet is saying yes. So that's really good. Nice, Shivam. Shivam is also saying yes. Okay, so in the class, whatever we have solved, you people have understood that, right? Okay. So now today, it is actually, this lecture is going to be interesting in the sense that today there won't be many mathematical problem as such. It will be just, intuitive kind of questions here today in this particular lecture. Okay. Okay, so let's get started. Now here, I was saying that time in our hand is RTT. What do I mean by that time in our hand? It means that from the moment that we are transmitting, I mean, we started the transmission until we get the ACK, right? So this much we were waiting in the stop and wait. But here in the next protocol, which is called sliding and window, we will not be waiting here. So the total RTT time is this much, right? This much is RTT. By the way, tell me, do we have enough evidence or enough resources where we say that this is also RTT? I mean, some universities say that this is also RTT, or some authors. Do you remember that? And I also told you that in the GATE PYQs also, I will show you that sometimes they have considered this also as RTT. See, maybe I can also show you. I mean, I don't have that in the slide today, but yeah. So see, this is from Washington University. Can you see the RTT they are measuring from where? They are measuring RTT from this last bit, right? I mean, not from the first bit. They are not considering the transmission time. Is this visible? Okay. I don't know if it is visible. So they are considering the RTT from the last bit, not from the first bit. Anyway, like I don't have that in the slide, but we have already discussed these things, right? So for our purpose, we will be considering RTT from the transmission time itself. I mean, from the very first bit. But some of the authors, some of the books, even right, they consider from this particular line. And the slide that I have just shown you, that was of Washington University, but they have taken this slide. If you, I don't know if you can read it, borrowed from Cross. They have taken this slide from the Cross book. Can you read this? I mean, this Washington University itself has borrowed this slide from some other book, which is a standard reference book. Okay. So anyway, sometimes the RTT is this. I mean, for some author RTT is this, but let's not worry about it. I mean, we have seen that, okay, like in the GATE PYQs, there want to be, basically I will show you, there want to be multiple answers, which means if you are considering this as answer, then it will be the option. Either the option will be considering this as RTT, or the option will be considering this as RTT, right? Anyway, let's just continue. So we have this much time in our hand. In stop and wait, we were wasting that much time, right? So this time was wasted in stop and wait. Now in sliding and sliding window protocol, we say that we will be keep on sending the frames for this much time also. This is the idea in the sliding window protocol, right? Okay. So now this sliding window protocol, as you can see, I have used this plural here. I have kept this s at the last. Why? Because this is of multiple types, right? So what are those types? These are of two types majorly. One is called go back and another one is called selective repeat. Okay. So this sliding window protocol is one idea that says that we can send, that says this is an idea that says we can keep on sending data, or maybe we can send multiple frames in RTT. You can write like this. We can send multiple frames okay. So this is of two types. One is called go back and another one is called selective repeat. Let's just first start with go back and. Okay. So what is this protocol? Let's just try to understand. Right. So what does this go back and says? I mean, what the sliding window protocol in general says basically is that we can send in this RTT time, right? This is the RTT time. Which means what is the RTT time? Can you theoretically tell me? RTT time is the time where we start the transmission till we get the ACK completely. So go back and also says that in this RTT time, in this completely, don't need to just send one frame. What you can do, you can send multiple frames. Okay. Till the moment you get the first ACK, this is the first ACK that we are getting. So till this moment, you can send multiple frames. That's what this go back and says. Okay. So we will be sending multiple frames here. I mean, that's what the sliding window protocol says, but go back and says that here, if you want to send multiple frames, then you can send, but the receiver, okay, I mean, you can send multiple frames, but the receiver will be waiting just for one frame. So there is something called window size. Okay. So the sender window size could be multiple frames. I mean, sender can send multiple frames here. Okay, maybe the frame number 0, frame number 1, frame number 2, something like this. But the receiver will be waiting just for one frame, which means it will be waiting first for frame number 0. Once it receives that, okay, frame number 0 has been arrived. Okay, this is the frame number 0. Then it will say that, okay, now I'm waiting for frame number 1. Once the frame number 1 arrives, then it will say that now I'm waiting for frame number 2. So basically there is a receiver window. This is called receiver window. This is called sender window. Okay, this is called sender window. So in go back n, the sender window size could be multiple, right? So here, let's suppose the sender window size is W, sender window size. So tell me, can the sender window size be greater than 1? Can this be greater than or equal to 1? Yes, right. The sender window size can be greater than or equal to 1. Can it be 2? Yes, 2 is allowed, 3 is allowed, like that, right? So all of this is allowed. Can this receiver window size be greater than 1? The answer is no. So receiver window size is always 1 in this go back n. What do these things mean? You will get to understand. Don't worry. Okay. So here the receiver window is always 1, right? Always 1. Okay. So I will tell you the working of go back n, but before that, let me just tell you 1 or 2 theoretical points. So it allows the transmission of new packet before earlier ones has been acknowledgement, which means, I mean, this is a general idea of sliding window, which means you can send multiple packets before this packet has been acknowledged. You can send this packet also. Okay. So you allow the transmission of new packets before the earlier ones are acknowledged. the sender has window of n packets that can be sent without acknowledgement. Which means if you are having window of, let's suppose, n equal to 4, then how many packets you can send without getting acknowledgement of anything? So you can send 4 packets. Okay. So let's suppose this is 0, 1, 2, 3. Then you can send packet number 0 without getting the acknowledgement of packet number 0. You can even send packet number 1 without getting the packet acknowledgement for packet number 1. You can send the packet number 2. And similarly, you can send the packet number 3. Can you send the packet number 4? Tell me, can you send the packet number 4 without getting the acknowledgement? The answer is no, right? So we will not be able to send this packet number 4 without getting the acknowledgement. Okay, what does these things mean? You will get to understand. But this n means that if n is equal to 4 means that we are allowing 4 packets to be in flight. In flight means outstanding packets, which means you can send those packets without even any acknowledgement. Okay, cool. So let's just see that what kind of acknowledgement it is basically using. There are basically multiple type of acknowledgements. One is called individual acknowledgement. That's what we were using in stop and wait. Okay, so this is what stop and wait uses. There is okay, don't worry about this TCP. I mean, these protocols actually also being used at TCP, so that's why this TCP might be written here, but you don't need to worry about this. Okay, so there is something called as cumulative acknowledgement. This go back and uses the cumulative acknowledgement. So what do I mean by that? See, this cumulative acknowledgement means that suppose you are sending packet number 0, packet number 1, packet number 2. Okay. Now suppose the receiver will be receiving these packets. Now suppose that you get acknowledgement for packet number 1. Acknowledgement for packet number 1 can be called as, can you tell me the ACK number here? I mean, the notation that we use is incremented one, right? If I'm saying acknowledgement for packet number 1, then it will be the 2. It will be 2, ACK 2. Okay. I mean, this is the notation that we are using. Now in go back end, we are using cumulative acknowledgement. So what does this cumulative acknowledgement mean? Interestingly, it mean here is that all the packets. So this ACK2 means that that packet number 1 has been arrived, and not just packet number 1. All the packets before packet number 1 also has been arrived. Okay. See, this cumulative acknowledgement. This is the cumulative acknowledgement. Cumulative ACK. So what does this mean? It means that all the packet before me also has been arrived. See here, this ACK says that got everything up to x minus 1. I mean, if the ACK number is x, if ACK number is 2, then it means that got everything up to 1, which means I have got 0 and 1. Okay. If this is cumulative. Suppose if this is just individual acknowledgement, then it will say got only the packet number 1, now expecting the packet number 2, right? There is also something called as negative acknowledgement. It says that I did not get x, maybe because the x is corrupted, or maybe I really did not get x. So there are 3 kind of ACKs. Okay, out of which this particular go back end is using cumulative ACK. Let's first focus on cumulative ACK, then you will get to understand other kind of ACKs also. I mean, we have already talked about this individual ACK also. Little bit we have talked about this negative ACK also, if you remember. Now, in this go back end, we will first focus on cumulative acknowledgement, and by the end of the lecture, you will get to understand each of this ACK again. Okay, so let's just first focus on cumulative acknowledgement. So have you understood that if receiver is saying after getting this 1, let's suppose after getting the packet number 1, okay, suppose after getting the packet number 1, if receiver is saying ACK2, then what does this mean? Does this mean that I have got packet number 1 only? No, it means that I have got everything till 1, right? I have got everything till 1, not just 1. So cumulative ACK, it means I have got till 1. This is what cumulative ACK mean, and that's what go back and uses. Okay, this was one point that I wanted to discuss. Now, one last theoretical point before I tell you the working of go back end is a timer in go back end. Do you remember that we were using some timeout timer in the stop and wait? I mean, we were sending some packet and then we were waiting for some timeout timer. Do you remember that? Right? We were waiting for some timer. Similarly, here also we will be waiting for the timer. Okay. I mean, there is nothing different here. So we will be waiting for timer here also. Which means whenever we send a packet, then we can start the timer. Now here, tell me, are we just sending one packet or we are sending multiple packets? We are sending multiple packets. Since we are sending multiple packets, okay, since we are sending multiple packets, we can have multiple timers also, which means that we can have timeout for this. I mean, we will say, okay, this is the timeout for this is the timeout for this is the timeout for this. We can have multiple timer also. But the thing here is that, I mean, if you maintain the multiple timer, then it is not very useful. I mean, it might be actually the overhead. Okay. The reason being is that, tell me, suppose if I say that this packet has been arrived, then do I need to really check whether these two has been arrived or not? If someone is sending me the ACK, okay, ACK of this packet, let's suppose this is 0, 1, 2. If someone is sending the ACK of 3, ACK 3 means I have received till 2. Then it means that I have received everything, right? So basically, I mean, just by looking at one packet, I'm able to say that I have received everything till now. Or maybe let's suppose this packet number 0 has not been reached. Okay. Okay, maybe let me do one thing. Let me first tell you the working of this Go backend, because after that you will get to understand. But for now, let me maybe quickly explain this timer also in 1 minute, and then after working you will get to understand. See, this is clear to everyone, right? If ACK 3 has been arrived, then it means that everything till now has been arrived. Okay. Now, can you tell me that what was the receiver window size here? Receiver is just waiting for one packet, right? Now, suppose I'm sending packet number 0 and packet number 0 has been arrived, let's suppose. Now, the receiver will be waiting for which packet? See, once this packet number 0 has been arrived, receiver will say, okay, now I'm waiting for only one packet, which is packet number. Can you tell me? Yeah, packet number 1. So now I'm waiting for packet number 1. So receiver always wait for only one packet. Now suppose the packet number 1 also has been reached. Now receiver will say, I'm waiting for packet number 2. Because it always wait for only one packet. Right? Now suppose there are multiple packets that we can send, and for example, let's suppose that this packet 2 for some reason get lost. Okay. Now in this case, let's suppose it is waiting, since it is waiting for packet number 2, and now let's suppose the packet 3 has been arrived. What it will do to this packet? Can you tell me? What it will do to this packet? It will discard. Yes. It will say, I'm waiting for packet number 2 and you are packet number 3. I will discard it. Right? I will discard it. Okay. So what if the packet 4 has been reached here? It will also get discarded, right? So if the packet is out of order, since I'm waiting for packet number 2, if the packet is out of order, I will discard that packet. Okay. Now, after some time, there will be timer for 2 that will get timeout. After some time, 2 timer will get timeout, right? And I will send this packet number 2 again. Now tell me, I mean, if you look at this 3 and 4, shouldn't I have to retransfer 3, 4 also? Because 3, 4 has been discarded here. Okay. So I have to again send 3 and 4. Okay. So 2, 3, 4 will be resent basically. So what I'm trying to say here is that if one of the packet is resent, then the following packet also has to resend here. So that is why although theoretically we can maintain multiple timers, timeout for 3 also, timeout for 4 also, but we will just prefer to maintain one of the timer. Okay. For the leftmost packet, you will get to understand the reason why. So this screenshot I have taken from Forogen. Let's just read it out, and then we will go about the working of go backend, and then you will get to understand the whole story. Okay. So what they're saying, although there can be a timer for each packet that is sent, in our protocol, we only use one. The reason is that timer for the first outstanding packet always expires first, which means they are saying the timer for this 2 is always expiring first, right? That is also true. And if you are sending 2, you anyway have to send 3 and 4. So tell me, 3 and 4 timer will be useful or just to be wasteful? If I'm maintaining 3 and 4 for timer, maybe it not be useful, right? Because if 2 timer is at getting expired, then anyway I have to send 3 and 4. And 2 timer will anyway be getting expired before 3 and 4. So that's what they are trying to say. Okay. Anyway, don't worry. In this 10-15 minutes, if you have understood anything, that is fine. If you have not understood, then also it is fine, because everything I'm going to tell you again. Okay. With the working of the go backend. These were 1 or 2 theoretical points that I wanted to discuss. Okay. Now let's just see that how the working is happening, right? Suppose that this is sender, this is receiver. Okay. Now you can send multiple packets at once. Let's suppose you can send 5 packets at once. Okay, the pack or the 4 packet or 5 packet, whatever this is. Yeah, this is 5 packets, 0 to 4. So let's suppose the packet numbers are 0, 2, 3, 4 or something like that, right? 0, 1, 2, 3, 4. These are the packet numbers. Now, I am saying that you can send multiple packets at once. Okay. Just try to understand here. You can send 0, you can send 1, you can send 2, you can send 3, you can send 4. And you don't need to get any acknowledgement to send this window. Okay. If window size is, let's suppose I'm assuming that window size is 5. Okay. Cool. Receiver is here, okay, which is waiting for just 1 packet. Receiver will say that, okay, if 0 has been arrived, this is the receiver. Receiver is first waiting for 0. If 0 has been arrived, it will be very happy. And now receiver is waiting for which packet? Receiver is waiting for the packet number 1. Okay. Now, if 1 has been arrived, receiver will be very much happy. And then receiver will say, see, I'm going to send cumulative acknowledgement. So cumulative acknowledgement means I will be sending acknowledgement after multiple packets, right? No, I mean, basically cumulative acknowledgement means that whatever I'm sending, if I'm sending ACK X, then it means that every packet till X minus 1 is arrived, right? So here, can receiver just send, okay, can receiver just send ACK2 saying that I have got 0 and 1 both. So what does this ACK2 mean here? See, do you really need to send ACK1 here? Do you really need to send ACK1 and ACK2, or just ACK2 is fine? This is my question. Just ACK2 is fine, right? So here, what I'm saying here, just ACK2 is fine. Now, interestingly, you tell me ACK2 is fine, that I agree with you. But interestingly, you tell me, is ACK1 and ACK2 both are wrong? Or both, I mean, sending ACK1 and ACK2 both are fine? Or ACK1, this is wrong or right? Sending ACK1 and ACK2 also works, right? It also works. If you send multiple ACKs, I mean ACK1 and ACK2, will this work or not? Yes, this will also work. I mean ACK1, if it gets to the sender, then sender will understand that, okay, packet till I mean packet number 0 has been arrived. From ACK2, it will understand, okay, a packet number 0 and 1 has been arrived. So maybe, I mean, this is fine, that sending, even though you have the cumulative acknowledgement, it is not the individual acknowledgement. First, try to understand. This is not the individual acknowledgement. This is still the cumulative acknowledgement. And we are always using cumulative acknowledgement in Go backend. This should be clear to everyone. In case of cumulative acknowledgement also, I'm saying that sending these individual, I mean, for every packet, if I'm sending ACK, it is okay. I mean, it is not wrong. It may be overkill. Okay. It works. but maybe overkill. That's what I'm trying to say. I mean, although not very much required, but you can do it. Okay, maybe overkill. Right? Yes. So I hope you understood. Okay. Now coming further to our this example, right? Let's just say that, okay, I mean, after some time, or maybe after some packets, I'm sending the ACK, right? Okay. Let's suppose that here I'm sending. It so happens that I'm sending after 2 packets. I'm sending some ACK. I mean, that's definitely possible. Okay. Or maybe you can have some timer and you can say that, okay, after 1 minute I will send the ACK. Okay. After every 1 minute I will send the ACK. Maybe you can say something like this. Anyway, doesn't matter. But I hope you understood that what does ACK2 mean? Everything till packet number 1, which means packet number 0 and packet number 1 has been arrived, safe and sound. Okay. Now it will be traveling. It's this ACK2 that we are sending, it will be traveling, and after some time it will be reaching to the sender, right? Maybe I can use different color here. Okay. So this ACK2 will be reaching after some time. I hope you understood. Okay. Now let's just see what this receiver is doing. Receiver is saying that I'm waiting for packet number 2. Basically, that's the only reason I have sent the ACK2, and packet number 2 also has been arrived. Let's suppose receiver will be so much happy. It will say that, okay, now I really need packet number 3. Let's suppose packet number 3 is also arrived. Receiver will say that, okay, let's suppose that I'm sending the ACK. Can you tell me now ACK number here that I should be sending? It should be ACK4, right? It should be ACK4. Why? Because I am saying that now I'm expecting packet number 4. Okay. Now let's suppose after some time this also has been arrived. Then this receiver will be very much happy, and this is the very normal working. Okay. I hope you understood a little bit. Cool. Now let's just try to understand this more. Okay. How this window is actually sliding. That's why it is called sliding window. I mean, this is a type of the sliding window, right? Cool. Is this working fine to everyone? That we are sending multiple packets and how the packet sending and the ACK is working. Basically, currently I just told you that how the ACK is behaving, right? And I hope this ACK behavior is okay to everyone. Now let's just see that how windows are actually sliding. So suppose that okay, so you are having, this is your sender and this is your receiver. Wow, straight lines. Okay, I'm really impressed with this tool then. Okay, cool. So there is a sender, there is a receiver, right? Now I wanted to show you that how the ACKs are behaving, right? Suppose, how the sliding window is getting slided. Suppose that we have some window. You can have any size. Maybe let's suppose that size is 5, just like previous. Okay, let's take size little less, or size of the window. Let's suppose the size of the window is 3, right? 0, 1, 2. Or let's suppose, yeah, 3 is good enough. Let's take the size of the window is 3. Or maybe let's say it is 4. Okay. Now, what does the size of the window mean? It means that we will be sending all of these packets without even worrying about the acknowledgement, isn't it? So just this 0, this 1, 2, and 3, all of them will be sent. The 0, 1, 2, and 3, all of them will be sent without worrying about the acknowledgement. Let me just keep it a little closer. Okay. Now suppose it is getting the 0. Although, see, always I'm saying it is a cumulative acknowledgement. Okay, so it is never individual acknowledgement in this go backend. Okay, the way we are using it. Cool. Suppose I get the ACK for 0. I mean, it can definitely send the ACK for 0 also. I mean, I have sent 0, 1, 2, 3, and after some time, I get the ACK for 0. What will the ACK number here? It will be ACK 1. Yes. Now, the moment this particular sender receives this ACK 1, what it is going to do, that's what I want to explain here. Now, at this moment, the moment I receive the ACK for this particular 0, I will say that, oh, great, 0 has been definitely arrived. That is why I can shift my window, okay, or I can slide my window. So what does this mean? It means that now my new window will look something like this. See here. See, previously it was containing 0, 1, 2, 3. Let's suppose this sequence number is 4. Okay. Now it will be containing, I will just slide it once. It will be containing 1, 2, 3, 4. Okay. See, earlier it was 0, 1, 2, 3. The moment I get this 0 acknowledgement for 0, I will slide this window once. That's all I'm saying. Okay. Cool. Now suppose, okay, just assume that you have many sequence numbers, which means, I mean, many packets to send, which means here, after here also, you have, let's suppose, many other packets. Maybe 5, 6, or let's suppose the sequence number I have just available till 0, or till 0 to 6, maybe. Okay. Then maybe you can say it is again 0, 1, 2. I mean, see, the sequence number, if I'm having here, is available from 0 to 6, I will say 0, 1, 2, 3, 4, 5, 6, then 0, 1, 2, 3, 4, 5, 6, then 0, 1, 2, 3, 4, 5, 6, like that, right? Is this sequence, is this numbering fine? See, whatever network layer is giving to me, I will number them 0, 1, 2, 3, 4, 5, 6. Then I will number them 0, 1, 2, 3, 4, 5, 6. Then I will number them 0, 1, 2, 3, 4, 5, 6. Whatever network layer is given to me, I will number like this, right? Okay. If I'm having only till 6, available sequence number is till 6. How to decide the available sequence number, that I will talk in a minute. Sorry, not in a minute. In the next lecture, I will talk. Okay. So here, if the acknowledgement for 0 has been arrived, I'm shifting my window, right? Cool. So I hope that is fine to everyone. So this window got shifted. Now suppose that I get, after some time, I get the acknowledgement, which is ACK 3. Okay. After some time, I get the ACK 3. Can you tell me that where will be the window now? What is the starting point of the window? If I'm getting ACK 3, it means I have got everything till 2. So what will the starting point of window? 3 or 4? 3, right? I have got everything till 2. I'm expecting 3. So basically, it means that sender will get to understand, oh, okay. I mean, everything till 3. Oh, sorry, everything till 2 has been arrived. That's why you are sending ACK 3, right? Everything till 2 has been arrived, which means I don't need, in my window, I don't need this 2. Now I can really shift my window. And what is the window size? The window size, if you remember, we are starting with the window size of 4, right? I can say window size here is 4. WS means window at the sender. Okay. So window size is 4. So in window, I can keep 4 frames at a time. So if I'm sliding once, then I will be sliding once more, and I will be keeping 4 frames at a time, right? Now suppose the next frame that I have is 5 and 6. Is this fine to everyone? See what is happening. The moment I get, now let me just explain you again. This was the initial scenario, right? Initially, I have, see, this is the initial scenario. Initially, I have 0, 1, 2, 3 in my 0, 1, 2, 3 in my window, right? Now, what happens that after some time, I get the ACK 4, let's suppose 1. The moment I get the ACK for 1, I will shift my window such that it is having starting at 1, which means it says that now like, I mean, receiver has not confirmed that it has got 1, right? See how many packets I have sent? 4 packets, 0, 1, 2, 3. But receiver has confirmed that it has only got till 1, till 0, I mean, okay. I mean ACK 1. So now I will be shifting my window such that I have, this is called head of window, okay. Head of window. sorry, base of window. This is called base of window. I mean, head or base, whatever you want to call, base of window. So at base, what I have? If I'm getting ACK 1, then I will be having 1 at base. Now, if I'm having ACK 3, then can you tell me what will the base? Base will be 3. Yes. So this is base. Why? Because the moment I receive this ACK 3, I will say that, okay, receiver is confirming me that I have received everything till 2. Basically, it is expecting 3. Although I have sent 3 already, but till now receiver has not confirmed it, right? So still, that is why I will keep this 3 in my window. Right? I will keep this 3 in my window. Okay. Is this fine to everyone? So the window size is 4. So here 4, then 3, 4, 5, 6, right? So window size is always 4. I mean, in this example, I'm taking the window size 4. So this is the initial window. The moment I get ACK 1, I will be shifting it 1. The moment I get ACK 3, I will be shifting till 3, right? I will be shifting till 3. So now the window is having 5, 6 also, right? I mean, earlier it was having 0, 0, 1, 2, 3. Then I shifted it, and then this is the situation after shifting, right? Okay. Okay. So let me explain you step by step again. Have you understood till this point that we are shifting till ACK 1? I mean, we are shifting because of this ACK 1, we are shifting 1, right? We are immediately shifting 1. Now, do you notice that in this, how many frames I have? 4 frames, which are 0, 1, 2, 3, which I have sent, right? Which I have sent. Now, can you tell me what is the new frame number that just got into the window? Earlier, it was outside the window. I mean, it was already here. I'm not saying it is not here. 4, 5, 6, everything is still here. But it was outside the window. Now, can you tell me what is there inside the window that is just new packet? This is newly inside, right? This is newly inside. Right? Understood? So earlier the inside was 0, 1, 2, 3. I have sent all 0, 1, 2, 3. Now, because of the ACK, I shifted it once, and this 4 got inside my window. Whatever is inside your window, okay? Whatever is inside your window, you immediately send it. You immediately send it. Send this 4 also. Is this fine to everyone? See, whatever is in window, that is always in flight. In flight means you always send it immediately. You have already sent 1, 2, 3, 4. Now you are sending 4 also. Why? Because window got shifted once. Now, okay, this is where you are sending 4. Now let's suppose you got ACK 3 also. Then you will be shifting such that the base of the window will be 3, right? So you will be shifting, and then base of the window will be 3. Now, can you tell me what are the packets that you will be immediately sending? Should you be sending 3, 4, 5, 6, or just 5, 6 again? See, just 5, 6, right? Sender has not said, receiver has not said anything about 3, 4. Has receiver said that, okay, I mean, or the timeout has been expired, or receiver said negative acknowledgement about 3 and 4 or something? No, right? So in this case, whatever the new packet, you will immediately send it, right? So whatever the new packet, you will immediately send it. Now, let's suppose that ACK, okay, after this, suppose that ACK 4, 5, which means ACK 6. ACK 6 has been arrived. Then what will happen? Can you tell me the base of the window then? It will be 6, right? Yes, it will be 6. So you will say that now the window will be containing starting from 6, right? Starting from 6. And depending on your numbering, it will be basically total size should be 4. So 6, and depending on your numbering, it will be either 7 or it will be 0 or something, right? Yeah, you can have 7, 8, 9, or you can have 0. Let's have 7, 8, 9. Doesn't matter, right? Okay. So these are the new packets that just got into the window. Now looking at this window, let's suppose, okay, after this window, there are multiple other packets. Let's suppose packet number 10, 11, 12. Looking at the situation, can you tell me what are the packets which are in flight? In flight means that are in air. In air means that are outstanding, which you have already sent. So what are the packets that I should be sending again immediately? I should be sending, say, 6 I already sent, then 7, 8, 9. The moment I shift the moment I slide, I immediately send 7, 8, 9, right? So see, till this 6, I mean, whatever is in the window, it should be here. It should be here. It should be in the window, right? This should match. The moment you have 7, 8, and 9 also in the window, you are immediately sending 7, 8, 9, right? Okay. Now you tell me, if someone tell you that this window is given to you, before that some packets are given to you, in window some packets are there, outside window some packets are there, right? These can you tell me what is the status of these packets? Yes, they had been sent and acknowledged, right? They has been sent and acknowledged. What about the status of this window? This is the window, right? Are they sent? So they are sent. Yes, they are in flight. Sent but not acknowledged. What about this? They are not yet sent, right? Not yet sent. Understood? Okay, it's very, very simple. You keep on receiving ACKs, you keep on sliding. That's all. Okay. If you are receiving, let's suppose at this moment, you immediately receive, somehow you receive ACK 9. Can you tell me what's going to happen if you receive ACK 9? Now, what are the packets in the window if you receive ACK 9? Immediately after that, what will sender say? 10, 11, 12 will be sent. 10, 11, 12 will be sent. And your new window will look something like this. Right? I mean, base will be 9, right? For the new window. And 10, 11, 12 has been sent. Are you going to send this 9 again? No, right? After timeout, we will send. After, if there is a timeout, we will send. It's not an issue. But I'm not going to send it again. I mean, without timeout. If there is a negative acknowledgement or there is a timeout, then we will send. Okay. Anyway. So let's just quickly repeat this normal working. Okay. And then we can go to the questions. See, you understood what is this cumulative acknowledgement? It means that if you are sending ACK2, it means that if you're sending ACK2, it means that the data packet 0 and 1 has been received, right? Okay. Now, this is the normal working. If the window size is 4, you send immediately 0 to 3, 0, 1 to 3. You send these immediately. Let's suppose you get ACK1. You immediately slide it once. Okay. You slide it once and you will be getting this as new window. The moment you slide, immediately send this packet 4. Whatever is in window, that is always in flight. That is always outstanding. Okay. Immediately send the packet 4. Let's suppose somehow you get the ACK 3, which means the base of window will be 3, 4, 5, 6 is in the window. You immediately send 5, 6 also, right? Are you going to send 3, 4 again just because you're sliding the window? See, from here, if you got the ACK 3, then this is a new window. This is a new window. Are you going to send 3, 4, 5, 6? No, right? We might send 3 again or 4 again, 5 again. It depends on the timeout or the negative acknowledgement. Just because of the slide, why will I send, right? There's no point in that doing that. This is actually some misconception of some students. That's why I'm telling you. Okay. Is there anyone who used to think that, okay, we will be sending this 3, 4, 5, 6 again? Okay. So Ravi is saying that he used to think. Yeah. So actually, I also heard from some students. So last year, I was teaching that they also think that, okay, I mean, this whole window will be sent, but there is no point in sending the whole window again, right? Just because the window got slide. We will be sending after timeout only. That's the protocol. I mean, that will be just following the algorithm. So the moment I receive the ACK 6, it means the base will be 6, and I will immediately shift from 6 to 789. 789, I will send again, right? And it will keep on happening, right? And the moment I get the ACK 9, I will shift from 9, 10, 11, 12, right? Like that. Okay. So that is how it is working. Is this okay to everyone? You understood? Now, okay. Now, let's just see that what if that some packet is being lost. Okay. So it was a normal working. Now, just a second. Let me just do one thing. Let me just, put a heading maybe, so that later on it doesn't be bothering to you that what was this, I mean, what I was explaining here. So here I was just explaining that meaning of cumulative ACK. Okay. Here I was just explaining meaning of cumulative ACK. Similarly, here also I was explaining the same thing. Okay. And now this is where I started explaining the working of, I can say, normal working of go backend, right? How window get slide. This is what I explained in these slides, in these upcoming slides. Okay. Now let me put another heading. Now let me just explain that what happens if there is some loss, right? What happens if data or ACK get lost in go back and okay. Let's just see. So suppose that you are sending something, and let's suppose again your window is here. The window I'm taking as the, let's just be consistent in the sense that window that I will be taking is 4. Okay, the size of the window will be 4, just to be consistent, right? So let's just say that here also the window size is 4, and this is 0, 1, 2, 3. Okay. So 0 to 3 is in my window. Suppose you're sending maybe 0, then you're sending 1, then you are sending 2, then you're sending 3, right? Suppose this 0 has been arrived. This 1, let's suppose, also has been arrived, right? Now, suppose that this receiver is sending the acknowledgement. What will the acknowledgement number here? It will be ACK 2, right? It will be ACK 2. Now, let's assume that this ACK 2 also has been received here, okay? So basically, this ACK 2 will be received. So let's suppose this also has been received. Now, the moment you receive this, I mean, the sender received this ACK 2, it will say that, okay, let me shift my window such that there will be the outstanding, I mean, the first outstanding packet will be 2. So the base will be base of the window will be 2, right? Understood? So it will say that, okay, let me shift my window from 2 to 6, 7, 2 to what? If the window size is 4, then 2 to 5. Always 4 in the packet, right? If the window size is 4, then always 4 in the packet. So here I will be sending 4 and 5 immediately after that, right? Okay. Now, now after this, so maybe let me make the diagram little, shorter. Okay. So suppose this is ACK2, and after the moment I get the ACK2, I will be immediately sending, the moment I get the ACK2, I will be immediately sending 4 and 5. Okay. In the earlier diagrams, I think, actually I should be writing this 10, 11, 12 here, right? 10, 11, 12 here, because the moment I get this ACK9, then only I will be sending 10, 11, 12. Anyway, I mean, this particular 10, 11, 12 should have been written it here. Anyway, this is fine. You will understand. So after I receive this ACK2, I'm sending this 4 and 5. That's fine. But now suppose this 2 is lost. If this 2 is lost, then what will happen? Then, and it has received. Let's suppose 3 has received. If 2 is lost, but let's suppose 3 has been received. Then what this particular receiver will do? It will say that, see, I'm waiting for 2 and you got me 3. I will discard it. Right? I will discard it. And then let's suppose 4 has also been received. Then what will happen? If 4 has also been received, then I will again discard it. If 5 has also been received, then I will again discard it. Are you getting why I'm discarding? Because I'm waiting for 2. I'm waiting for 2. Now there are multiple options to discard. I mean, if you want, you can silently discard. Or if you want, can you do something for the fast transmission? See here, this 2 will be sent only after timeout, right? So if you want, you can silently discard. That's not an issue. But if you want, you can also say, see, I mean, this is one option. Don't worry, we will just stick with one option. I'm just telling you the possibility here. We will be just sticking with the silent discard option. But what could be the possibility here? Here I will say, see, I'm discarding it, but I'm waiting for 2. So it is again going to send ACK2. What does this ACK2 mean? That receiver, the sender will say that, okay, it is still expecting 2, but I sent 2. Pata nahi kya hua hai. ठीक है, maybe 2 is delayed or something. But it is discarding. Then it is again saying, see, I'm expecting ACK2. I'm expecting 2. Then the sender will say that, see, are you expecting 2? Let me immediately send 2 without even waiting for timeout. Are you understanding? That's called fast transmission or the fast retransmission. That's what we will see again in TCP. That's why I'm not talking about it much. Okay. So by the way, you understood what is this fast retransmission? That instead of silently discarding, I'm saying ACK2 every time, such that the sender will again get to know this it is still expecting 2. So let me not even wait for the timeout. Let me immediately send this 2. Right? If you are expecting 2, then let me send this 2. So, I mean, I can ask for this fast retransmission of 2, or otherwise I can silently discard. So let's just stick with this option where I am silently discarding. Okay. So it will discard, and after timeout, what will happen? After timeout, you will send this 2, then it will accept this 2, right? It will accept this 2. Now, interestingly, after timeout, since it knows that, see, what has happened, that 2 it is going to send this 2, but will this alone 2 will suffice, or it has to send 2, 3, 4, 5? It has to send 2, 3, 4, 5, right? Because if 2 has not been accepted, 2 has been lost. If 2 has been lost, then the sender knows that 3, 4, 5 must have not been accepted. It must have rejected 3, 4, 5, right? So that's why if you are sending 2, then you will not only send 2, you will send 2, 3, 4, 5. Okay. Have you understood? So basically what is happening here? What is happening? That you will not only send this 2, you will send 3, also, along with 2, 4 also, 5 also. Whatever is in the window, you will not just send this 2. You know, if 2 you are sending, then this window also has to be resent. And that is why it is called go back n. Okay, go back n means you go back and send all the n packets. All the n packets. I mean, although you have sent this 3, 4, 5, although you have sent this 3, 4, 5, but you go back and send all the n packets. That's why it is called go back n. Okay, so what is happening here? Let me just try to explain. You are sending 0, 1, 2, 3, and then you receive ACK2. Then you will be very happy. You will immediately slide it, and then now in the window 2, 3, 4, 5. You will be, after receiving 2, you will be sending 4, 5. But unfortunately, this particular packet has been lost. Because of this particular packet has been lost, that is why it will be doing what? It will be, the receiver will be basically discarding everything else. Since you have sent 3, 4, 5, it doesn't matter to the receiver. Okay, although you have sent 3, 4, 5, it will discard it. And then after timeout, you will be sending this 2, and not just 2. After timeout, you will be sending 2, 3, 4, 5. Okay, cool. Now, you tell me one thing. Suppose this is 0, 1, 2, 3, 4, 5. Okay. Suppose this is your, okay, suppose this is your window, 0, 1, 2, 3, 4. Okay. Suppose window is having just 3 packets at once, which means the window size is 3. Okay. I'm telling you that the sequence of events. Okay. Suppose that event 1 at sender. Okay. These are the sender. What sender observes. Sender got ACK1. So what you will send again? Then what you will do? Sender event 1 is at the sender side. I'm writing. Yes, in order packet has to be received. So this is sender side. Okay. So you sent, let me write this way. You send 0, 1, 2. Okay. You send 0, 1, 2. And in window, you have 0, 1, 2. Right? Because you sent it. But now you received ACK1. After some time received ACK1. So you will do what? You will shift the window and you will say that, okay, 3 is also in my window. Right? Now, let's suppose you also send, whatever is in the window, you will anyway send it. Now, let's suppose here at this particular moment, 1 has been received, but 2 has lost. Okay. So packet number 2 has lost. And you received ACK2. Then what you will do? You will do one thing. You will slide the window. You will say that, okay, if ACK2 has been received, let me slide the window. And in the window, I have 4, let's suppose. I will send the 4, right? I will send the 4. So I will send the 4 because that is in the window. But since packet 2 has been received, has been lost, this packet 3 and 4 will also be discarded. So after some time, timer for the packet 2 will be out. So you will say timeout will happen for packet 2. So what you will do? You will resend which packets? Now you tell me. This is 2, 3, 4, right? 2, 3, 4 is what you will resend. So see, from here, if you say that, okay, this ACK1 has been received, then you will say that, okay, let me just shift the window and let me send this 3. Whatever is in the window, I will immediately send it. Now packet number 2 has been lost, and then you will receive, let's suppose after some time, you will receive the ACK2. which means that receiver is still expecting the ACK 2. So till ACK until packet number 1 has been received, so you will immediately slide the window and you will say that, okay, I'm waiting for the acknowledgement for either 2 or 2, 3 or 4. But at this moment, let's suppose that you don't get any acknowledgement and timeout expire. I mean, the timer for the packet number 2 expire. Then you will resend 2, 3, 4. Okay, you will resend 2, 3, 4. So after this, I mean, you have already sent 0, 1, 2, 3, 4. Then you are going to resend this 2, 3, 4. Okay. So till this moment, how many packets you have sent? Eight packets, right? Okay, 8 packets. Cool. Now there is one interesting thing, which is that we have said that we are using timer for just one of the packet. I mean, that's one of the strategies that we are using. Now here what we are saying that we will be using timer for only outstanding first packet, this 0 packet, because if this timer expired, then I anyway have to send all of them, right? Is this fine to everyone? We will be just maintaining timer for just 0. Now here I'm maintaining timer for 0. Here I'm maintaining timer for which packet? Can you tell me? For packet number 2. Yes. Here I'm maintaining timer for packet number 2. Okay. So here in this case, I'm maintaining timer for packet number 0. Here I'm maintaining timer for packet number 1. Here I'm maintaining timer for packet number 2. Understood? For the first packet, we will be maintaining the timer. That's for the written in the Forogen. Okay. If you see the Forogen, I mean, this screenshot is taken from Forogen, that they are saying that we will be maintaining in our protocol, we will use only one. Okay. The reason is that for first outstanding packet, we will be maintaining the timer. Is this fine? Now, interestingly, can you tell me that here we are maintaining timer for 0. Now, when I am going to start this timer for 2, currently I'm not maintaining timer for 2, but when will I start this timer for 2? Here I'm maintaining timer for 2, but when will I start? The moment I send it or later on? What do you think? Are you getting my question? See, my question here is that here I'm maintaining timer for 0. Is this fine to everyone? Okay. Okay. Here I'm maintaining timer for 2. Is this fine? Yes. Now you tell me, this timer for 2 will get started where? At this point or at where? Yes, whenever this 2 is on the base, okay, whenever the window is at 2, whenever I get the acknowledgement of 1, okay, then only I will start the timer for 2. Whenever this is at base, okay, then only we start the timer. Is this fine? I mean, that's not very much important. That's just an implementation detail that I'm just telling you. But this is one of the strategy that get applied, right? So basically, if that is at the base, the moment it becomes the base, I start the timer. Okay. So it means that the moment I get, if this sequence number is X, the moment I get the acknowledgement for X minus 1, I start the timer for this, because then that is the moment it becomes the base of the window. Okay. So when we are starting the timer, the moment it becomes the base of the window. Okay. So see, we are sending 0, 1, 2, 3. It doesn't mean I'm maintaining timer for 0, timer for 1, timer for 2, timer for 3. No. Okay. I'm currently only maintaining timer for 0. The moment I slide, then I start maintaining timer for 2. See, tell me when I sent 2 here, right? I mean, I sent 2 even before. I sent 2 maybe before, but the moment I send this 2, am I starting the timer for 2? Tell me. No, right? The moment I send 2, I'm not starting the timer. The moment I receive the ACK for 1, or the moment it get at the base of the window, I'm starting the timer. Okay. I mean, these are just implementation detail. Okay. You might not need to know this. It will be given in the question if there is a question regarding that, right? So they will tell you that how they are maintaining the timers. But this looks one of the logical thing, that whenever it becomes the base, I will start the timer. Okay, I mean that's what the practical protocols apply. Okay, now let's just do one thing. Maybe you understood that how this data lost is happening. Similarly, the ACK loss will also be happening. But before that, we can do few of the questions so that this protocol will be in your habit. Okay, so let's just do few questions maybe. Okay, let's do this question. What they're saying, this question I have taken from UCSD University. So what they're saying, assume that there is a sender which is having the size of window is 3, right? So sender window size is given to you is 3, which means, let's suppose the packet numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that. Then you will be first sending 0, 1, 2. Then based on the acknowledgement, I mean, if you're receiving the acknowledgement, let's suppose for 1, you will be, I mean, ACK 1, you will be sliding it. Now, let's suppose you receive ACK 3, you will be sliding it till 3, like that, right? Okay. So the window size is 3. That's what they're saying. Cool. If we have to send 10 frames in total, which means maybe 0 to 9, 10 frames in total, and channel of transmission is such that every 5th transmission is lost. So they are saying that every 5th transmission is lost, which means you will be sending this 0, 1, 2, that's fine. But which one will be lost? Here, this 0, 1, 2, 3, 4, this packet number 4 will be lost. That's what they're saying. Okay. Which means you will be keep on sliding based on the ACK, but there will be a moment that 4 will be the base. Are you getting my point? See, initially, this is the case that 0, 1, 2 has been sent. But after some time, you will be sliding it, and then probably, okay, you will be sliding it, and probably you will say that this 2 is base, or maybe 1 is base, right? Then 1, 2, 3. Then you will be getting some acknowledgement. Then let's suppose you got ACK 3, then 3, 4, 5. Then you will be sending. Then you will be sending this 3, 4, 5. I mean, depending on that whether you have sent something before or not. So you will be sending basically some packets here. Then you will be sliding, right? Now tell me, can you slide further? Can you slide this further? No. Why? Because you will not be getting ACK for this. That's what they are saying, that this packet 4, or maybe the 5th transmission is lost, right? Okay. So I think here it won't matter. In this particular example, I can start the numbering from 1, right? I mean, doesn't matter. So let's just start the numbering from 1, just to make things a little easier. Okay. So let's suppose we are sending from 1 to 10. Now, initially, this 1, 2, 3 is in the window, right? And then you will say what? Let me just shift it. So you will keep on shifting, and there will be a moment that 5, 6, 7 is in the window. Now tell me, will you be able to shift it further? No, right? Because the 5 is lost. So that is why you need to basically, till this point, you have sent 1, 2, 3, 4, and then 5, 6, 7 also you have sent. But since 5 is lost, you need to again send this 5, 6, 7. The whole window, right? The whole window you need to send. Okay. Now, they are saying that every 5th transmission is lost, but no ACK. How many data transmission, including both original transmission and any necessary data transmission, does the sender make in total if the go back N protocol is used? Okay, cool. So let's just see this. So see, this 5 is lost. That's why I'm sending 5, 6, 7. Now every 5th packet means this is 1, 2, 3, 4, 5. Now 7 will be lost. So if 7 will be lost, so you will be basically having in the window 7, 8, 9. Now, if this is lost, you will be again sending 7, 8, 9. Now 1, 2, 3, 4, 5. Okay, so 9 will be again lost. At that moment, you will be having 10, right? At that moment, you will be having 10. And then you will be sending 9 and 10. Now, the fifth packet, 1, 2, 3. There is no fifth packet here. So these are all the packets that you need to send. Have you understood? So how many packets you are sending? Basically, you are sending, you can say, whatever is in the window, right? This 3 plus 3 plus 2, 6, 7, 8. 8 packets you are resending again. Okay. So 10 plus 8, which is 18 total transmission. Okay. Yeah, this is the diagram that they have given. 18 frames in total were sent. See, I don't know if it is visible or not, but yeah, this fifth is lost, and then the seventh is lost. 7, 8, 9, they're again sending, and then this 9 is lost. Okay. Cool. Now, this is a question from GATE 2006, and this question is exactly same as what we have just solved. Okay. Instead, they have just changed one thing. I mean, as I told you that I will almost for every question, I will be able to tell in computer networks one-to-one mapping from the university questions. So this is from UCDS, and they have just asked the exactly same thing. The only change that they have done is basically 9 packets from station A to station B. Window size is 3. Yeah, I think only from 10, they have just made it 9. That's the only difference. Okay, Satyam is saying how the ACK, how the window is getting slided. See, I know that everything will be received, right? I mean, only 5 will be lost. Other than 5, everything will be received. So it doesn't matter if window is sliding quickly or it is sliding slowly, which means from 1 to 3, it is directly, I'm directly getting ACK 3, it is directly sliding for 4, 5, 6, or maybe slowly, maybe from 1 to 3, first is got slided to 2, 3, 4, maybe, then it got slided, maybe let's suppose after that 4, 5, 6, whatever it is happening, but ultimately it will get stuck at 5. That's what I'm saying, right? Ultimately it gets stuck at 5. Okay. And then you will not be able to slide after this 5. Right? Is this doubt clear? Maybe it will get clear with more examples. So let's just do more examples here. Let's do this question. So what they're saying, in go back and ARQ protocol, everything is ARQ, right? The window size is 6. The segments with the sequence number 1, 2, 3, 4, 5, and 6 have been sent. Segments 7, 8, 9, 10 are waiting to be sent. So they're saying 1, 2, 3, 4, 5, 6 has been sent. Okay. So these has been sent. Now, ACK might not be received, but yeah, they have been sent. And waiting to, the sender just received an ACK for segment 2. ACK for segment 2 means what should be the number? ACK 3, right? I mean, ACK for segment 2 means ACK, I mean, the segment 2 has been arrived. So basically, they are saying ACK for the segment 2 has been received. So now you will slide it, right? It will get slided. What are the packets sender will send immediately after receiving ACK 2? Can you tell me? ACK for 2? What is the answer here? Will it be sending 3, 4, 5, 6, 7, and 8 immediately after receiving ACK for 2? Or just 7 and 8? Just 7 and 8, right? So that's why C is the correct answer here. Okay. Yes. Now, let's just continue this particular question. This is the continuation of the same question. What they're saying, sometime later, the sender transmitted segments like, I mean, after some time, it has got received, let's suppose something ACK. So 20 to 25, which are the 6 frames, right? Or 6 segments that it has transmitted. So which means 20, 21, 22, 23, 25. However, segment 22 is lost. 22 got lost. If go back and is used, what segments would it be sender have to retransmitted? If this has been lost, then So if 22 got lost, so it means that window will not be able to slide after it, right? I mean, the base will be 22. Now they have not given that whether 26 and 27 is there or not. Let's suppose that 26 and 27 is also there. In that case, you will be retransmitting whatever segments will have to retransmitted. They're only asking about the retransmission. So they're not asking about the 20 new transmissions. So since they're only asking about the retransmission, so retransmissions for the only is for 22, 23, and 25. Okay. Retransmission is for 22 to 25. Understood? Okay. Now let's do this question. What they're saying, consider sending 10,000 packets using go back n with n equal to, n means n is the window size, okay? N equal to 10. So you are sending 10,000 packets and at once you are sending 10 packets. Suppose a scenario where the packet from the sender is lost. Happens 10% of the time. So 10% of the packet get lost, right? What will the maximum number of packets to be sent? Okay, so 10% of the packets get lost. Then what is the maximum number of the packets to be sent? Do you want to give a try? Okay, so this is a typo. You can consider it to be 1%. I mean, the 10% is also fine, but it will be too much actually. So just consider it to be 1%. And let's just solve this question. Okay. So if these are 10,000 packets and 10% of those packets, sorry, 1%, I'm assuming it is 1%, right? I mean, let's just consider this is a typo. So if 1% of the packet are being lost, then can you tell me how many total packets are being lost? Out of 10,000, right, of 1%. So you can say into 1% equal to 10,000 into 1 divided by 100, which will be 100 packets, right? So the 100 packets will be lost. But interestingly, it may so happen that these 100 packets, every of this packet may lead to, what is the maximum number of transmission it may lead to? See, these are the 100 packets which may lost, but every of this packet may be leading to the, so whenever the packet get lost, it is leading to retransmission of not just this packet. It is leading to, because the window will get stuck at this point, right? It will lead to, this one packet will lead to the retransmission of all of these 10 packets, right? So if 100 packets are being lost, then the retransmission will be happening is 100 into 10 into n, which is the window size, into 10, which is 10,000. Sorry, 1,000. Okay. So basically, for the 1,000 packets, there will be again transmission. I mean, there will be retransmission of 1,000 packets. Is this fine to everyone? So if only 100 packets are being lost, then also in go back n, because it will get stuck, right? Window will not slide. If window is not sliding, then it will get stuck. If it is getting stuck, then you are going to send all of these n packets. So that is why 1,000 packets needs to be retransmitted. But interestingly, this 1,000 packet, whatever are being retransmitted, this 1,000 packet maybe will also be having the 1% loss. That's what they are saying, right? So you have your 1,000. I mean, you are retransmitting 1,000, but not just 1,000. There will be 1% of 1,000 which will be lost again. So 1,000 into 1%, it will be 10 packets will be lost again, right? 10 packets means that which means into n, right? Into n, which is 100 packets you need to retransmit again. So 1000 you need to retransmit, then 100 you need to retransmit, then 1% of this will be again lost, right? So which means 1% of this, if it is being lost, then this will be one packet you need to retransmit, but not just one. How many packets? Into n, 10 packets, right? 10 packets. So first 1000, then 100, then 10 packets you need to transmit again. Then 1% of this will be again lost. So what is this number? 1% of this will be 0.1 only. So that will be lost, which means, I mean, I can say just 0.1 packet or just one packet will be lost. So if you send that again, then you just, you maybe, okay, that 0.1. So should I be considering that as a one packet? I think no, right? I mean, that will be just +1 -1. Let me just see that what they're considering. Okay, they're not considering this. Anyway, so basically 10 packets you will be sending, and 1% of 10 packet is just 0.1. Since it is lesser than 1, let's just ignore this. Okay. So if 0.1 packets are being lost, then let's just ignore this. If 0.1 packet is lost, right? Okay, understood. So that's why you need to add all of this, which means 10,000 anyway you have to send, and then 1,000 you have to send, and then 100 you have to send, then 10 you have to send, right? These many 1 1 1 1 0. These many total packets you have to send, and the retransmission will be 1110. I mean, if you only consider that, okay, what is the extra packets that you are sending? So the retransmission is this. This is the retransmission. Okay, I'm only considering retransmission here. This is retransmission. So this particular question I have taken from this university, UNSW. Okay, I think this is a good question, right? Yeah, I mean, we can generalize it most probably. This will be some sort of GP. Yeah, that is correct. Okay. So have you understood, by the way, this question? That see, you will be 1% packet will be lost. So there will be 1% of this 10,000. There will be 100 packets will be lost, but not just 100. That is the problem. I mean, 100 into n, 1,000 packets will be lost at maximum, right? If 1,000 packets are being lost, then it means we need to transmit them again. That means 1% of this will again get lost, which means 10. And not just 10, because of the go back n, 100 packets. And that's how you need to solve this question. I think this is a very good question, right? Okay. This is total number of transmitted packet. I mean, the retransmission is this much. Okay. Now let's solve this question. What they're saying, as shown in this diagram, the receiver send ACK2 and ACK4. Okay, I mean, the sender is sending P0 to P5, but receiver is sending cumulative acknowledgement ACK2 and ACK4. ACK2 get lost while ACK4 is successfully received by the sender. Okay, what will be the action that sender will be taking for the lost ACK2? See, sender is transmitting P0 to P5. This has been lost, and it is sending cumulative acknowledgement 2 and 4. It is sending 2 has been lost, and then this 4 is received. So what will sender do for lost ACK2? What do you think? Yeah, see, will not do anything, right? Nothing. It will not do anything for lost ACK2. It has received ACK4, it will be just sliding the window. That's all. It will not be doing anything. It doesn't worry about this ACK2. Doesn't even know whether ACK2 has been sent or not, right? Understood? Won't do anything. It has received the cumulative acknowledgement, which is ACK4, which is nice one. So it won't do anything. Okay, this was the question that I've taken from this university. But this question is actually having two parts. They're asking that this was the complete diagram. I have broken down that into two. So this ACK4 has been received, and after that, the moment it has received ACK4, let's suppose it is also sending more packets, right? Suppose 6 and 7. And then this P4 is also received after this ACK4, but it was some corrupted packet, let's suppose. And now I'm sending this negative acknowledgement. See, the negative acknowledgement is always optional. If you want, you can directly discard it and then let the sender handle it using timeout. But I can send the negative acknowledgement also, saying that, see, it was corrupted. Can you send it again? So it will receive the negative acknowledgement 4. Now, what it will do? What the sender will do after this? So it means that ACK2 was missing, but ACK4 has been received, right? ACK4 has been received means 4, 5, 6, 7. That is in the window. I mean, I9, whatever, right? So this is in the window. Now here they are just using till 7. So this is in the window, right? Yeah. Now, let's suppose you have the data till 7 only. Okay. Now, if there is a problem with this 4, if you are saying that, okay, the 4 acknowledgement has not been received, instead you have got confirmation. You see 4 का acknowledgement तो नहीं मिला, but ये भी confirm हो गया कि 4 में कुछ गलती है. Okay. 4 has some corruption. Okay. So it means that anyway you have to send this 4 again. So you anyway have to send after this 4, whatever you have sent. So 4, 5, 6, 7 you have to send. So what it will do for missing ACK2 is basically nothing. What it will do for this? Send or maybe resend 4, 5, 6, 7. Okay. That's all. I mean, that's how we can do this question. Just easy question, just to make sure that you understand this particular protocol quite well, right? Let's see this. Indicate the window and base variable. Okay, there's a base variable. Base is the starting of the window. Okay, so you want to indicate the value of these 3 parameters immediately. Okay, so these parameters immediately following the sender event. So basically, let's suppose that this is if you send packet 0, then this is the window and the base is 0. If you send packet 1, then can you tell me what will the window? If you send the packet 1, can you tell me the base of the window? Yes, it is still 0, right? I mean, the moment you receive the ACK, then only you will slide the window, right? The window is still containing this. If you send packet 2, then also window is containing this, base is still 0. If you send packet 3, then also window is containing this and base is still 0. Is this okay to everyone? The moment you receive the ACK1, receive ACK1 means that you can have this base starting from this, and then you send this packet 4, and then at this moment the base will be 1. Okay, you receive the ACK2, which means now you send the packet number 5, immediately you send the packet number 5 and the base will be 2. You receive ACK2. Okay, that's interesting. See here what is happening, that let's suppose that this particular packet number 2 is timeout, which means this packet 2 has been lost, let's suppose, and then at the receiver I'm getting 3, 4, 5. At the receiver I'm getting 3, 4, 5. Okay, the way they have implemented is little interesting. The moment you are getting 3, so do you remember what this receiver will do the moment it gets 3? It will discard, right? See, suppose that 2 is lost. Okay, I'm assuming that 2 is lost, and then you have sent 2, 3, 4, and 5, but 2 is lost. The moment it receives 3, what it will say? Discard. Now at the discard, you might be having multiple options. You can silently discard, and one of the options that I just briefed about is that you will say, see, I'm discarding but not silently. I might say that, okay, ACK2, I'm expecting ACK2, I'm still expecting ACK2. Okay, you can say I'm still expecting. Is there anything wrong with that? I mean, the moment you are getting 3, you will say that, okay, I mean, you are sending me 3, but I'm discarding it, and also I'm expecting AC 2. That's why I'm sending AC 2. So if you notice here, it has got ACK2 multiple times, right? Received ACK2, which means expecting to. So maybe it is because that 2 has been lost, and they have also shown later on that 2 has been lost, right? 2 has been lost, and also, I mean, they have received multiple ACKs for 2. What might be reason that 3, 4 might have been received, and at 3 also I'm sending ACK2. The moment I receive 3, I will discard it, sending ACK2. The moment I receive 4, I'm discarding it, sending this ACK2. Okay, and then after the timeout is there. Okay, so now can you tell me what is the window here? What is the window base? Must be till this point, because I have not received acknowledgement for this. Must be till this point. Here also must be till this point. Okay, good. That's what they're asking. Now, in the same question, they are saying that after the last event, packet 2 is timeout. Okay, after this last event, what packets must be resent by sender? 2, 3, 4, 5, right? 2, 3, 4, 5. Okay. This is the answer. 2, 3, 4, 5. I mean 2 to 5. How receiver decide which cumulative ACK to send? I have not got to the question. Which ACK to send? How receiver decide? I mean, whatever receiver is expecting, it will decide based on that, right? Receiver has just one window. I mean, whatever is expect, let's suppose 0 has been received and 1 has been received. And then it is expecting 2. So it will say I'm expecting 2. So ACK 2. Whatever it is expecting, next it will send that particular ACK. Right? And if you say it is expecting 2, see here what is happening, that it is expecting 2, but you are sending 3, right? I mean, what is happening, that this is 2, 3, 4, 5, right? And then 2 has been lost. Now it is expecting what? Can you tell me the packet number the receiver is expecting? It is expecting 2, and you are sending 3. What it will do? Discard. You are sending 4. What it will do? Discard. You are sending 5. What it will do? Discard. Now it will discard. That is fine. That is called silent discard. But what else you can do extra apart from the silent discard? I mean, you can silently discard. That's not an issue. But what you can do extra, which is very much optional, is that you can say that, see, I'm expecting 2 ACK2, right? I'm expecting 2 ACK2. Instead of silently discarding, I'm sending ACK2 again. What is the benefit of this ACK2 again? This is optional, first of all, but what is the benefit? Yeah, fast transmission. The sender will get to know कि यार बार-बार पूछ रहा है, भेज ही देते हैं. I mean, let's not worry about कि ये timeout कब होगा. Okay. I mean, you can send after the timeout, but if it is asking again and again, maybe you will say, okay, I will not worry about the timeout. Let me send it again. That's what we do in TCP. Okay. We will see it later on. That's called 3 duplicate ACK. Has everyone studied this before? 3 duplicate ACK in TCP? Okay, that's what we do in TCP. I mean, TCP practically implement this fast retransmission. Okay, we will see this later on. For now, I'm just telling you one idea that, okay, I mean, you can silently discard, but you can also say that, okay, I'm expecting this much. Okay? Cool. So, should we start selective repeat protocol today? Or maybe we can start tomorrow, right? Have you understood a little bit of go back end? I mean, selective repeat and go back end will be mixed. That's why I'm first telling you the idea of the selective repeat, and then we will be having the mixed questions. Okay. So after the selective repeat, this if you see in the questions, there will be the mixed questions of selective repeat and go back end. Okay. And there are very, very good questions that I have now on. Okay, some questions are extremely good that I have for the selective repeat and go back end. So there are some questions which are very, very good. Okay, just based on some intuition that, okay, what it will send, what it will not send. No mathematics. See, in all of these questions, we were not having any mathematics, just understanding that how the protocol work, right? That's all what we were doing in these particular questions. Now, in selective repeat, once the selective repeat is over, then also we will be seeing some mixed questions of the how the protocol works. That okay, which AC cable we send, what will not be sent, and so on. Right? Once you understand that okay, how the working is happening, how the ACK and data is getting sent or not, then we will be doing some questions related to numericals. I mean, some mathematical questions which are involving some numbers. Okay, efficiency, throughput, and these things. Right? Okay. Yeah, I am working on the quiz. So first, I will be uploading one quiz on the memory management in 1 or 2 days, and then we will be having computer networks quizzes. Okay. So thank you, everyone. Take care. Bye-bye.